Hello everybody, I'm Bob Axe, I'm a guitarist. I would like to share with you some of the modifications I have done to my Behringer FCB1010 or 1010 MIDI foot controller. I have to admit that this is not my preferred foot controller, but depending on the jigs I have, I may carry with me a lot of things, the big rack with a lot of foot controllers, or I'm forced to carry with me the lightest equipment possible, because for instance there are a lot of bands, so the exchange of bands must be very rapid, and so in that case I use the FCB because I have a lot of things in a compact controller and a light rack to carry with me. The other option is my keyboard for my feet, and in that case I use ROLAND FC-200, the GFC 50, everything is ROLAND. ROLAND is my preferred brand for a lot of things, including the MIDI foot controllers, and it's very reliable, no problems for years, or hard use on stage. So this is my first choice, but not always I can carry with me all these and my full rack. I have done 6 modifications on the standard FCB controller in order to meet my demanding needs. Be careful that each of them will void the warranty of the product, so it's up to you to apply one or more of them. First of all, I have replaced the firmware EEPROM inside of the FCB controller with an unofficial one from a Belgian guy called UnO firmware. I will tell you the details later, but it will enhance the possibilities and flexibility of your controller. The second modification is regarding the power supply. When possible, I don't like to have the mains of my devices on the floor because it may rain, a beer can be spilled here, so I prefer to have low voltage when possible. And also I prefer typically to have just one cable for everything, not a lot of cables. So here I have MIDI signals and also power supply. You see, it works. In my version of the FCB there is an error in engineering the sensors inside, so it is impossible, even using the adjustments inside the menu, to get the full control of your parameter from one end to the other end. It will experience a part of the movement where it is not possible to change the parameter. So an easy to be done modifications inside will solve this problem if you have in your FCB controller. Since the buttons here and the expression pedal are too close, it is very easy to touch and move the expression pedal while pressing the button, so I added this aluminium shaft to avoid it. I liked this control button on my FC200 MIDI controller, so I was able to get the same functionality on the FCB controller. I reversed the two buttons like this, so I have down and up here, and this button in a more ergonomic position may act as a program change then, or now as a push on, release off control change to control effects and parameters on the rack. So you see, push on, release off, push on, release off, of effects, parameters and so on. I have also replaced all the micro switches inside the controller, placed below each button and soldered in PCBs. The reason? Because of their very low quality. Probably Behringer have saved say 20 cents maximum instead of using a better quality products. On the other side, on stage, I got a lot of problems of reliability. For instance, if you experience the pressing the up button once, it increases 2 or 3 times, and the same opposite for the down button. The reason is the quality of the micro switches that have to be replaced. So this is the back of the FCB controller. To remove the back of the FCB, you have to unscrew the 3 and 3 side screws and these 6 screws and these 4 screws. Okay, these 3 and 3 are a little longer than the others, remember it. This is for the ground wire. I already removed it, but there is another screw here. So this is the internal of the controller. Very briefly, here there are the sensors. The sensors are optical. Probably they save some money doing this. Power supply area, the main CPU, and 2 boards that are for the foot controllers and to hold the LEDs. This is the original EEPROM installed inside the FCB controller. It's a memory that have inside all the programs that run the controller. Do not touch with the fingers like this because it's a static sensitive device. I have replaced it with the UnO version of the same firmware, modified by a guy from Belgium, and it can be downloaded from this address. If you have an EEPROM programmer, you can download the code free, or you can purchase from here, I think 24 euros, $30 about, the EEPROM with the new programs inside. It allows a lot of features not available as standard in the FCB. Here you have the download. Okay, and I have found very useful to download also a Windows programmer like this. You can download it here. It will allow you to speed up a lot the programming of your controller, and it is compatible with UnO and the standard EEPROM. It is a beta version, but the bugs are really minor bugs, so I use it without particular problems. You have to know that MIDI connections just require 2 wires, this one and this one. Okay, a third is used just for shielding. So typically the MIDI cables use 3 wires connected to these 3 pins of a DIN connector. The 2 pins at the opposite positions are typically unused in MIDI cables, and typically 90% of the cables, of MIDI cables, have just 3 wires inside, not 5. So obviously to carry additional signal we have to build a new cable. So my strategy was to connect the power supply in these 2 pins just to supply the low voltage part of the foot controller. So what I have done is just to add the power supply in the back side of my rack, a power supply like this one. 500 milliamps are enough for the FCB controller, and the 2 wires of the output of the power supply are connected to the external pins of the DIN socket for the MIDI connection. Okay, like this. I prefer to use professional DIN connectors like this because they have golden contacts, because they are more rugged, and also they have this screw that tighten the connector in order to have fixed and stable connection with the rack. I have chosen also a cable enough thick to carry the current with less losses of current as possible. Since we are dealing with low voltages, you know that it is very important to have enough thickness in the cable. On the other side I have the other connector, and this can be put inside the socket here. Obviously, on the interior part of the FCB, I added the wires to carry inside the current. The two brown wires are just soldered in the two pins unused and carried onto the power section of the FCB. The power section has a diode bridge, then a stabilizer, 7805 capacitors, and so on. I decided to connect the two brown wires instead of connecting them directly to the power supply. I passed through a bridge, another bridge that I added. 1 amp bridge is enough in order to be secure that any reversion of the voltage will not damage the controller. So in this case there is just a bridge here, this one, and connected the output plus and minus to the plus and of the diode, the bridge diode of the power supply. That's it, and it works fine. The voltage I'm using is 9 volts DC direct current. So I put the connector here. I put the connector here, and it turns on. The other problem that I solved in the FSB controller is regarding the expression pedals. The control, the real controller of the parameter was not in the entire movement of the pedal. So in the last part of the movement, it was impossible to change any parameter, regardless of any adjustment you do in using the menu of the controller. I investigated and I found a reason why it happened. Let's talk about this typical controller, what they use inside. Typically they have inside a potential meter, and you see, the pedal makes with a shaft, the gear rotates and changes so a volume or a parameter. Obviously this is an old design, but inside the Roland expression pedals you find the same mechanism but with a higher quality, obviously recent technology. A very precise control and a good feeling in the movement of your feet. In this case it is difficult to have the same feeling because it is very easy to move them because they haven't the resistance in the movement that there is here. They decided to use an optical system that may appear to be more beautiful, but in this case not. There is an emitting diode on one side, and on the other side there is a sensor that receives the light emitted by the LED. In the middle there is this transparent piece of plastic that has designed in it 50 shades of gray, possibly 10, and so moving the pedal they obscure a little or more the light received by the other sensor on this side. What happened that probably due to some tolerance not considered by the engineers, that the light emitted by the diode is too much or the sensitivity of the receiver is too high. So in the last part of the movement the receiver is saturated by the light. so 100%. So even changing the light received, it stays at 100%. The solutions could be to add a resistor to LED or to change the receiver polarization. I have found a very simple one, just wrapping around the sensor, the receiving sensor, some plastic from a shopping bag. So the lights received is reduced. You may laugh about it. And now I'm really able to adjust the sensitivity of the two expression pedals from 0 to 127 from here, lower position, and the upper position. Okay? You see, I start from 0. As soon as I move it, it changes. And when I found the end position, it reaches 127. This board have 16 micro switches of better quality, and it cost from China something more than $1, including the shipments. Okay, changing the micro switches below the buttons makes it possible to have a better reliability of the buttons. So regardless of how you push them, perfectly aligned or with an angle of your feet or the other angle, they works always. So now it's reliable. The micro switches are placed here, 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 here. The button simply touches a micro switch like this, touches and switches your effect. Okay, so here there are a lot of micro switches like this, soldered with 4 pins. You can see it. Okay, the micro switches used in the FCB are very low quality. You may find in internet, even in eBay, higher quality for probably a couple of dollars for all the micro switches you need. I suggest you to use the version a little higher, like this. You see, it's a little higher than this. And then in the screws that hold the boards, add a washer on the other side below, in order to place the PCB a little higher, so to compensate partially the more height of the button, but obtain a better action without a risk for the button. Japanese engineers studied correctly, in my opinion, the ergonomics of the FC-200, letting enough space between the button and the expression pedal, 5 centimeters, in order to reasonably avoid to touch the expression pedal while pushing the last button. On the contrary, the Chinese or German, I don't know, engineers of Behringer just leave 3 centimeters here that aren't enough to ensure this, and it happened a lot of times in my jigs to touch and reduce suddenly to 0 the volume of my guitar while just pressing the down button or now the control button with my modifications. So this shaft avoid this problem completely, because now it is impossible to touch expression pedal. Okay, and it leaves enough freedom, it doesn't disturb the action of the expression pedal. It also protects the upper button enough, and the maximum that may happen is to a little increase the volume, but what it is disturbing is to reduce to zero the volume of the guitar unexpectedly. This special part I have made it using T aluminum bars, plus I have found this one with a rounded edge, aluminum too, and I have done this two supports with the T-bars. It takes patience and time to find the right measurements, but it's more easy than may appear, and the position of the bar more or less is the same of the pedal in the maximum position, so it is impossible now with your foot to touch this and decrease suddenly the volume while pressing the new control button or the old down button. In this part it is not so necessary to have the protection, but since I have it I decided to prolong to this position. Then to fix it to the FCB here I used simply a double-sided tape that is enough strong for that purpose. Clean the surface first. This is just to show you a modification I have done later of the shaft. I cut away the angle, this angle, because I have found that it stopped the run of the expression pedal, avoiding it to reach the real end position. Now it works perfectly. If you see, the position of the shaft is real close to the expression pedal, just enough to avoid to be touched, and this is the best compromise I have found doing several tests, because in this case it doesn't disturb a lot your action, your movement with your foot here. If you put the shaft more close to the button, on the contrary, you will have more difficulties to work with it, because of the difference in height also of the two. Okay. One thing that I wanted to have in my FCB foot controller is to have a control button. This control button is used, for instance, to deactivate an effect like Stombox, or to change on two levels a parameter, and doing mainly in two ways: push on, release off, or push on, push off. To do so, I have sacrificed one button of my FCB. So the number 10 could be used now as a 10, all the same, or as a push on, push off, press on, release off parameter control, or effect on off control. This modification works only with the UnO EEPROM. So what I have done is to reverse the plastics of the buttons. It's easy to be done, unscrewing one screw here and here, and exchanging the plastics. Here I have done a hole to make it possible to see all the same the LED regarding the 10 button. So its LED remains on that position, because here I added a new LED to check my operations on the control button. On the other side of the board, I isolated the button, this button, and the other button here, and I carried the wires of one button here and the wires of this button here. This was the first stage of my modification. Then I wanted to add the functionality of press on, release off, temporary change of a parameter or an effect and so on. So to do so, it's more complex than this, because I needed to add an additional board, and this is an Arduino board, a Mini Pro Arduino 5 volts supply. Arduino is easy to be programmed with C++ language from a PC with its dedicated editor and compiler. So you may write the operation that you want to do with the circuitry and then perform the tasks. In this case, I just check the pressure of a button and then write the signal for the Behringer CPU. So to make it appears as a button pressed by someone, in reality it is pressed by the Arduino board. So this Arduino board simply receives the button pressure and converts the pressing into press and release, and the release of the button into again press release of the button. That's why it is possible to make it work like this. Press, release, press, release. And then from my GT Pro I'm able to decide if I want a toggle operation, press on, press off, or a normal operation, press on, release off, of any parameter I want. Obviously this is for advanced technicians, but for anyone interested I can supply the board already programmed. Here you can see below the hot glue that there is a transistor and a resistor. This is why, because the signals from the board can be 0, 5 volts, are good to drive external circuitry, digital circuitry. But in this case the buttons are connected with the main CPU with a rectifier, a diode, that have the cathode of the diode towards the button. So it is required to drive current from the CPU down to the ground. Arduino cannot do it, so also because the reference is not the ground but a common wire in the buttons. So what I have done is to drive an NPN transistor through the resistor in order to open the collector emitting connection and drive the current down to the common wire. Obviously the board requires some power supply, 5 volts, so I connected the board to ground and 5 volts from a capacitor of the integrated circuits here. The green LED that you have seen before is connected to the board, and the board is capable to change the level of the light of the LED very easily with a command. Some word regarding the Arduino board. I have chosen it because it's cheap, have many possibilities to control inputs and outputs, digital or analog signals, and it is a standard way of programming with C language for different versions of the same CPU. I have chosen this one, very little, cheap, with 13 inputs for some output and so on. But there are other types of Arduinos, like this one that has already the USB connector and the converter, so you can use it directly connecting to the USB of your computer and use it. Then you can unconnect and place it where you have to do this. This is another one, doing Lenovo. There is the Arduino UnO. This is the biggest one, the Mega, with a lot of 54 inputs, a lot of outputs, and this is another version, very powerful, with a very powerful CPU inside, a lot of serials and so on. But what is interesting is that to program boards you can use the same editor and compiler, that's this one, and you just need a USB connection. In this case, since there is not the USB in the board, I have it separated. I just need to put it into the socket like this. Okay, the editor senses it. When I want to program my CPU, just press the compile and load button. It starts to compile the program, and if there are no errors, it loads it, and then when the lights goes on, it finished the loading of the program inside the Arduino. That's it. Okay, now it's ready to go. Tuck. In this case, since there are a power supply coming from the cable here and another power supply here, it's still on. I added just a Schottky diode in serial with the power supply of the Arduino in order to avoid that the voltage from here may came into the Behringer main CPU. So it is only possible the opposite, to carry the current here to supply the Arduino board.